Road to Olympiad.
Welcome to RTO. Consider the following problem. Find all the sets of positive integers x1, x2, x3 until x20 such that xi plus 2 square is equal to the LCM of xi plus 1 and xi plus the LCM of xi and xi minus 1 for I is equal to 1, 2, 3 until 20, where x0 is defined as x20, x21 is defined as x1, and x22 is defined to be x2. LCM have some nice property to play around. It is not necessary that the LCM of two big numbers must be greater than the LCM of two small numbers. Can you spot the pattern on the axis to figure out the set of integers that works? Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that none of the xi can be equal to 1. Else, say if xi plus 2 is equal to 1, we have 1 square is equal to the LCM of xi plus 1 and xi plus the LCM of xi and xi minus 1, which is greater than or equal to 1 plus 1, since the LCM of any two integers must be greater than or equal to 1. And thus the sum is 2. This is clearly a contradiction. So there must be some prime number p for each j between 1 and 20 inclusive such that p divide xj. Now notice that xj divides the LCM of xj plus 1 and xj plus the LCM of xj and xj minus 1. Since both of them must be a multiple of xj and thus must be divisible by p. This implies that p divides xj plus 2 square, or simply p divides xj plus 2. By inductions, we can tell that p must divide xi for all I with the same parity as j. In particular, since p divides both xj and xj plus 2, it must divide the LCM of xj plus 2 and xj plus 1 plus the LCM of xj plus 1 and xj as well. This implies that p divides xj plus 3 square, which in other words divide xj plus 3 as well. So we know that p does not only divide xi with I having the same parity as j, but also with I having the different parity as j as well. In other words, p divides xi for all integer I. Putting this aside, now if we sum the inequality for I from 1 to 20, we have this one. And also from the rearrangement inequality, we have this, where the equality holds if and only if all xi are equal. Notice that 2 times the sum of LCM of xi plus 1 and xi must be equal to 2 times the sum of xi times xi plus 1 divided by the greatest common divisor of xi plus 1 and xi, by the fact that the product of LCM and GCD of two numbers is equal to the product of the two numbers themselves. This is less than 2 times the sum of xi times xi plus 1 divided by p, because the greatest common divisor must be at least p, since p divides all xi. And this is less than or equal to 2 times the sum of xi times xi plus 1 divided by 2, because p is a prime and p must be at least 2. Cancelling the 2, we have the summation of xi times xi plus 1, which by the rearrangement inequality just now, we have it to be less than or equal to the sum of xi square, which is equal to 2 times the sum of LCM of xi plus 1 and xi. Here we see that this whole thing is an equality, and in particular, for the rearrangement inequality part to hold, we need to have each xi to be equal, say equal to k, for all I between 1 and 20 inclusive. With this, back to the given equations, we have k squared is equal to k plus k, since the LCM of k and k itself must be k. And thus, we have k squared is equal to 2k, which gives us k is equal to 2, since k is positive. Therefore, the only set that works here is the set of all 2. And this marks the end of our solutions. Post in a comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.